Do subscribe to eKida channel and press bell icon to get updates about latest engineering, HSC and IIT-JEE main and advanced videos.
Students, today we'll discuss about another physics paper, JEE Mains Physics 2014. So let us discuss all those questions one by one. Okay. Students, let us move to the next question. The question is the radiation corresponding to 3-2 transition of hydrogen atom. This is second orbit, this is third orbit. Transition is from 3 to 2 of hydrogen atom falls on a metal surface. So the radiation corresponding to this falls on a metal surface. So whatever radiation comes out, that falls on a metal surface. Suppose this is a metal surface, the radiation falls on this. So after it falls on this metal surface to produce photoelectrons. So photoelectrons will come out. Photoelectrons will come out because we know that due to photoelectric effect, that when light radiation of certain suitable frequency greater than the threshold frequency will fall on this, then an electron will come out with various kinetic energies. So the electrons are coming out with different kinetic energy. These electrons are made to, so there are many electrons that is coming out. If these electrons are made to enter a magnetic field, how these are made to enter magnetic field, whether the magnetic is parallel to this or perpendicular is not given, but it says that if the radius of the largest circular path followed by these electrons is this, so that means the magnetic field is definitely perpendicular, because without perpendicular magnetic field the electrons will not rotate. So for the rotation of the electrons entering in a largest, these electrons that's coming out will move like that in a circular path. In a circular path of this radius, suppose R is radius, largest circular path means this radius is maximum. R is maximum. Radius of largest circular path followed by these electrons is 10 mm. So this R maximum value is given as 10 millimeters. So we have these situations. The work function of the metal is close to. So you have to find the work function of this metal. Suppose this work function of this metal is phi. You have to find the value of phi. This is the physical situation. Now, if now the energy that is falling is E. The energy that is falling on this is E due to this transition, and this is the work function, and the rest goes to as the kinetic energy. And this kinetic energy, we're considering those electrons which are having maximum radius. So if it moves in a maximum radius, then the kinetic energy is also maximum. So we are talking about those electrons which have come out with maximum kinetic energy. So therefore the kinetic energy is maximum. Okay. Now we have to write the relation. When the transition is made from this to this, then what will happen? Now the situation is clear. We have data. In data we have got B, the magnetic field, which is 3 into 10 raised to minus 4 Tesla. The transition is occurring from 3 to 2, and the radius, maximum radius is 10 mm. The work function is to be found. We know that there is Einstein's photoelectric equation. From photoelectric equation we know that the energy that is incident E goes into two ways, in the form of work function and maximum kinetic energy. This equation is based on the principle of conservation of energy. Now this phi we want to find is E minus Ke maximum. Now to find that Ke maximum, we can get the value of phi only when these two are known to us. E is the total energy, and that comes from the transition of 3 to 2, the energy that comes out, it is nothing but E2 minus, so E3 minus E2 mod. This is the energy that comes out. So the amount of energy, obviously it will get released. That energy is this energy, and this is a hydrogen atom, and we know how much energy is released in case of hydrogen atom transition, because we know that this is a minus, we know that the first level energy is minus 13.6 and this is minus 3.4, and that one is, if you don't know, then we have to use the formula, and this is divided by 9. If you divide by 9 here, then 1 4 6 9 5 9 1 1.51. So these are the number, these are the orbit number, and this is the actual energy of the electron in those orbits. So the transition is from here to here, so I can have the difference. So it is 3.4 minus 1.51. So that goes to, if I take 10 here, then 9, then 13 8, and 1 goes there, that is 1 point, yes. So 1.89 is the amount of energy that is released from here, and these are in electron volt units. These energies are electron volts, and therefore this energy will also be in electron volt. So I can substitute this value of E. So from here I got the value of E as well. From here I am getting E value as 1.89, okay, electron volt. Now then I have to write this kinetic energy also in electron volt, then only I can subtract. Now to find in this equation 1, we have got one value, and we have to find, we are looking for this kinetic energy maximum. We know that in a magnetic field, when electrons enter in a magnetic field, then the centripetal force is provided by electrostatic force of attraction between the electrons, and the force will act like that. So it will move like this, because the force is the force constantly is perpendicular to, is acting toward the center, and the particle moves in a circular path. By the formula that mv square by r equals to E V B QVV sin theta. Sin theta is 90. This is a relation that everybody knows, that this is the force due to magnetic field, because once QV enters in a perpendicular magnetic field like that, QVB, the force is like that. So V is like that, the force like that. Once it, so it will continue in a circular path. So from here and I want kinetic energy, so R goes to this side, no problem. Then mv square is this, so half mv square equals to EV by 2. So this is kinetic energy. So what I have here is that kinetic energy maximum is here I'm getting as EVBR by 2. The velocity is also not given, so I have to again modify that expression, because kinetic energy is also p square by 2m. Kinetic energy is p square by 2m, so I have to find this p. So I will go back to the basic equation. QEV is mv square by r. So from here 1v goes, okay, 1v goes, so mv by r is equal to qb, or p from here, this is p, this p equals to qbr. So kinetic energy maximum equal to p square maximum by 2m, which is q square b square r square divided by 2m. Okay, now if I solve this, that should be in this is actually the electron, so one electron I keep outside, and then it will be in electron volt. So this will be E b square r square by 2m electron volt. You can see here q square here is nothing but E square, and I have just kept one E, the other E is here and becomes electron volt. So therefore this is the unit. Therefore the EVB, I will just put the value 1.6 10 raised to minus 19 is the value of this electron, and magnetic field is given in the question as 3 into 10 raised to minus 4 Tesla into our radius is 10 mm, so 10 raised to minus 3. So you have got b square, you have got r square divided by twice into m. M is the mass of the charged particle. Here is the electron. It's not given in the question, but you know that the mass of the electron is 9.1 10 raised to minus 31 kilogram. So by substituting and putting all those values, now then this is in electron volt. Now approximately you have to solve everything. Okay, you don't do, because you don't have so much time, so you do just solve approximately. I will write that also, what will be the approximate value. But anyway, this is minus 4, this is minus 8, so minus 12, and minus 12, and this is minus 12 and minus 31, so that will cancel out. So all this square, this will cancel out, so this whole thing will cancel out, this will cancel out, this will cancel out, this will cancel out from the square itself. Now what is left is 1.6 into 3 divided by 2 into 9.1. I will approximately take it as, okay, 9, simplify 8, 3 3 is 9, 2 8 is 16, so 0.8, 0.8 by 3, this is approximate calculations. This is 8 by 30, 3 into 1 by 10, then that comes out to be how much it comes out to be 0.8, 16 by 10, 2 8 is 16, 8 by 10. And so this comes out to be, so from here you can see that this is 3 square, it's 9, so 1 3 will be here, 1 3 will be here. So if I look at this, then this is 0.8, approximately it is 0.8. So this is not required at all, and this will cancel out 0.8. So in the next page you can write that the kinetic energy maximum comes out to be nearly is approximately 0.8 electron volt, and the transition from E3 to E2 gives that energy is already we have calculated, that is 1 point how much we got last time. From that we got 1.9 1.89. okay, last time we got this 1.89. so this I will write approximately 1.9. this is 0.8. so if I subtract these approximate values, then my phi from equation 1, if I see the equation 1, the equation 1 was the total energy and minus the Ke maximum. This is the formula. So this is your E value. I put here it is 1.9 minus this kinetic energy maximum value 0.8. All these things are in electron volt. If I subtract that approximately, I will get 1.1. And that surprisingly coming out to be the exact answer. Our approximation also gives you the exact answer. So 1.1 is the correct answer. This is the answer, 1.1 electron volt. So this is 1.1 electron volt. So basically what I've done is, you can see here what I've done is, the transition of this 3 to 2 electrons, this radiation is allowed to fall on the metal plate. Then whatever energy that is falling on this is the energy difference, which is E2, E3 minus E2 or E2 minus E1, whatever it is. Now that amount of energy that is released here, which is we know that that is also energy in third level is minus 13.6 divided by 9 minus 13.6 divided by 4. If you solve that, that comes out to be 1.89. So 1.9 approximately. 1.9 electron will falls on this. Some part goes to the work function of this phi of the metal. The remaining goes to the electrons and moves in a circular path. Now it moves in a circular path of greater radius. So therefore, I will have to relate the magnetic field with the magnetic field force with the centripetal force. So with that, we have one relation, and according to the data we are given R and B. So in the form of kinetic energy has to be expressed in the form of R and B. Then we got the expression for kinetic energy as P square by 2m, and P is the momentum that we got from the this equation mv, so centripetal force and magnetic force balance. So from that you get the value of P, and then kinetic energy is P square by 2m. After that, finally what we have done, you kinetic energy got P square by 2m, and whatever is there is one important thing, that if I put all those values here, then I will get kinetic energy in joule. But all in this chapter mostly they are the energies are expressed in electron volt, and the given radiation also is in the form of electron volt. So to convert to electron volt, what I have done is, you take you keep E outside, so that then this will become the electron volt. If I multiply E, then it will become joule. So I keep one E out. So out of this square I have only taken one E. Then you substitute the values, and you don't have to go for exact calculation. The way I have calculated, you will also calculate, and then you will get the answer. If you go for exact calculation of 9.1 and 2, then this, then you'll waste lot of time. Therefore, you take this a 9, take this a 3, take this, if you are cutting is okay, otherwise you can take 5, 1.5 also. It is 8, 2 is there, so it's okay. If it is 2 is not there, then you can take 5, 1.5 also. It's 3 by 2. That will help you cancel out. So finally, by squaring it and everything, I got 0.8. So this 0.8, then I finally substitute in my given equation, then I get 1.1. Okay, thank you.